Imagine a piece of technology launched before many of us were even born,
Right.
hurtling billions of miles away, still working decades past its use by date.
It really does sound like science fiction, doesn't it?
It does, but it's the real story of NASA's Voyager program. And just recently, the team pulled off something, well, pretty extraordinary.
Bring those dormant thrusters back online on Voyager 1.
Exactly. So in this deep dive, we're going to unpack the sheer ingenuity, the problem solving that went into reviving these absolutely crucial systems.
And what makes it so remarkable, I think, is the scale. Voyager 1 launched way back in 1977.
77.
Yeah. It's now about 15 billion miles out. That's what, 25 billion kilometers from Earth?
Just staggering numbers.
It is. It's actually in interstellar space now. Its twin, Voyager 2, is also out there, maybe 13 billion miles away.
And they're unique, right? The only probes to send back data from beyond the heliosphere.
The only ones. They're the only craft that have ever sent data from, outside the sun's bubble of influence.
Yeah.
Their first job was the outer planets.
Jupiter, Saturn.
Uranus, Neptune. But this extended mission, it's been this incredible push into totally uncharted territory, interstellar space.
And keeping in touch, that relies on these thrusters. Now, these aren't like the big launch engines.
Oh, no, not at all. Think of them more like precision instruments. Very fine control.
Okay.
They're used to pivot the spacecraft just tiny amounts up, down, left, right.
Why is that so important?
Well, it's all about keeping that main antenna pointed directly back at Earth. That's how we get the science data and, crucially, how we send commands to it.
Got it.
And there are also other thrusters for roll motion. It's like rotating the spacecraft to keep it oriented using a guide star.
And there are backups for those.
Yes. Primary and backup sets for the roll thrusters, specifically. The ones used for trajectory correction during planet flybys. They can't do the roll.
Okay, and it was the primary roll thrusters on Voyager 1 that failed. Way back when.
That's right. They stopped working back in 2004.
Wow, 20 years ago.
Yeah. The issue was traced to their internal heaters losing power. And the thinking at the time, the engineering assessment, was that fixing them was pretty much impossible.
So they just relied on the backups.
For 2 decades, yes. The mission depended entirely on that backup set of roll thrusters to keep the antenna pointed home.
So, okay, fast forward 20 years. Why suddenly try to fix the unfixable primary thrusters now? What changed?
Well, it really comes down to managing risk on these incredibly long missions. There were growing signs, basically, evidence suggesting the fuel lines for the backup thrusters might be getting clogged.
Okay, so the backups might fail too.
Exactly.
Yeah.
And if you lose roll control entirely, if both sets fail, well, that's potentially catastrophic for the mission. You can't point the antenna, you can't get data, you can't send commands.
Game over, essentially.
Pretty much. So the potential reward of getting those primary thrusters working again, even as a backup to the backup, suddenly seemed worth the risk. So the team took another look.
Right, they didn't just accept the old diagnosis.
No, they started thinking, what if it wasn't a permanent hardware failure? What if something else happened?
And the new theory was?
The revised idea focused on the electrical circuits, the ones feeding power to those heaters.
Okay.
Engineers started to wonder if maybe some kind of, electrical glitch, an anomaly, had just flipped a switch, cutting power.
So not broken, just switched off.
Potentially. The thinking was maybe, just maybe, if they could send the right command to flip that switch back, the heaters might power up.
And the thrusters would work again.
That was the hope. Talk about troubleshooting from billions of miles away.
Seriously. But wasn't there also a ticking clock, something about a big antenna going offline?
Yes, absolutely. Adding to the pressure cooker situation, the Deep Space Station 43, DSS-43.
The one in Australia.
That's the one. It was scheduled for a major offline period for upgrades. We're talking months, from May 2025 to February 2026.
And why is that antenna so critical?
DSS-43 is, well, unique in the deep space network. It's the only antenna with enough power, enough signal strength, to reliably send commands all the way out to the Voyagers.
No other antenna can do it.
Not for commanding them reliably at that distance, no. So the team had these brief windows, little moments in August and December, when DSS-43 might be briefly operational during the upgrade period. They were aiming for those windows to get this sorted.
Just in case the backups failed while the main command antenna was down.
Precisely. Talk about pressure.
And these upgrades to DSS-43, I assume they're important beyond Voyager.
Oh, hugely important. They're critical for future stuff like supporting crewed missions back to the moon, the Artemis program.
Right.
And they'll also boost capacity for lots of other deep space science missions, some of which are, building directly on what Voyager discovered in the first place.
Okay, so the stakes are incredibly high. Failing backups, a communication deadline, and this, let's face it, long shot plan to revive 20-year-old thrusters. What did the actual procedure involve? It sounds nerve-wracking.
It was definitely delicate, highly planned, but yeah, inherently risky. They had to send the commands to turn on these dormant thrusters.
Which hadn't fired in 2 decades.
Exactly. And then try to restart the heaters. The big risk was, well, the spacecraft uses a star tracker to stay oriented.
Okay.
If that tracker drifted off its target star while they were doing this, the thrusters were programmed to fire automatically to correct the orientation.
Right, a safety feature.
Normally, yes. But if they fired without the heaters working, because the fuel lines were cold, it could potentially damage the thrusters, maybe even cause a small rupture or explosion from frozen propellant.
Mm-hmm.
So keeping that star tracker locked on was absolutely vital.
Wow. Okay. So a real nail-biter.
Absolutely. It was a gamble, but a calculated one.
And then after all that planning, all that tension,
Yeah.
it worked. What was that like, getting the news?
It must have just been incredible for the team. So the commands went up on March 20th, 2025.
Okay.
Now, you got to remember the distance. Radio signals take, what is it now? Over 23 hours, just one way.
23.
Yeah. So they sent the command and then had to wait almost a full day just for the signal to get there, let alone get confirmation back.
That's patience.
Isn't it? So the telemetry, the data stream from Voyager 1 finally starts arriving back on Earth.
Yeah.
And within about 20 minutes of receiving that data, they saw it. A rapid jump in the temperature readings from those specific thruster heaters.
No way.
Yes, that quick temperature rise, that was the smoking gun. It meant the heaters were on, the command worked,
No.
the primary roll thrusters were potentially back in business.
Wow.
Yeah.
Just wow. A 23-hour wait and then confirmation in 20 minutes. The relief must have been immense. What was the mood?
Oh, absolutely through the roof by all accounts. The mission's propulsion lead apparently called it a miracle save.
I can believe it.
I mean, these were thrusters everyone had basically written off for 20 years, considered dead hardware. And it came down to the persistence, the clever thinking of one of the engineers revisiting that old problem.
It's an amazing story. Reviving tech considered broken for 2 decades on a machine billions of miles away. It really speaks volumes about the engineers, their dedication, their brilliance.
It really does. And, stepping back, it also highlights what NASA does, right?
Yeah.
Exploring the unknown, pushing the limits of technology, figuring things out against the odds.
It's more than just keeping an old mission going.
Much more. It's about that relentless drive for knowledge, the innovation that space exploration demands. It's problem solving on an epic scale.
So as we wrap up this deep dive, what's the big takeaway for you? What should people really think about after hearing this?
Well, I think it raises some really profound points about how we manage technology over these vast timescales and distances. Think about keeping these complex machines going, diagnosing problems decades later, billions of miles away.
Yeah, the challenges are mind-boggling.
They are. It makes you appreciate things like redundancy, designing for adaptability, and just sheer human ingenuity when unexpected problems crop up years down the line. I mean, what does this tell us about our ability to understand and maybe even reactivate parts of complex systems we thought were lost, even when they're practically in another star system?
That's a really powerful thought. And it definitely makes you wonder, doesn't it? What other dormant potential is just sitting there in the technologies we already have, waiting for someone to look at it differently, for that creative spark?
Exactly, waiting to be reawakened.
Something to think about for sure as Voyager 1 continues its lonely journey outwards.